Who all have joined? Abir. Assalamu alaikum, Abir. How are you?
Walaikum Assalam, sir. I'm good. What about you?
I'm also good. Thank you. How are you, Fatima?
I'm good, sir.
Okay. Good. So let us start with the charge on colloidal particles. Okay. Charge on colloidal particles. Like most of the colloids that we have, most of them, they will have some or other kind of charge, like positive charge or negative charge, they will always have. Okay, so let me just give you a table that mentions all the positively charged salts and the negatively charged salts. So this is just a information type of thing. You don't have to memorize the whole table, but please keep it in your notes so that you read it something, because you can't remember all of these things. I don't want all of you to remember it, but we will study the origin of charge. How does the charge originates in the colloids, and that mechanism you have to understand that mechanism, and that can be asked. Okay, that can be asked. So this is charge on colloidal particles. So there are a few things which have positively charged, and there are a few negatively charged salts. Okay, there are a few negatively charged salts. Now we'll study about how the charge is being originated. How is the charge being originated? There are a few methods. We write the origin of charge, how the charge is originated. Origin of charge. So this is more important here. Okay, this is more important. So the first origin of charge, like the first source of origin of the charge, is friction between the colloidal particles and the dispersion medium. So whenever you have some type of friction, there is static charges formed, right? Static charges formed. You must have seen those experiment in your childhood. When you rub scale on your hair, there is some static charge, and you can pick up small little cuts of paper cuts, right? So static charges formed due to friction. So this is the first reason, is due to friction between which particles? The colloidal particles and dispersion medium. And dispersion medium. The second source of origin of the charge is the dissociation of molecules. Okay, so when some molecules will dissociate, so there will be cations and there will be anions. There will be cations and there will be anions. Now, furthermore, what will happen? Some parts of this anion. So let me write the reason first. That is the aggregation. Dissociation followed by aggregation. Dissociation of molecules, which is followed by the after dissociation we will have ions, so those ions will get aggregated, followed by aggregation. Aggregation of ions. Third is, if you have metals, then metals, they have free electrons, and those free electrons are the reason why metals, they conduct electricity, they show lustrous property, they also show color, right? So when you have free electrons, then the electron can be captured when the colloid particles, they are dispersing around the metal. So the next reason is the due to electron capture, during electron dispersion of metals. Now the fourth reason that we'll look in detail is the preferential absorption of ions. Preferential adsorption of ions. Okay, preferential adsorption of ions. This is we are going to look in detail. This is we are going to look at detail. So in preferential adsorption of ions, we'll start with an example. Let us take silver nitrate solution and add it to potassium iodide. Okay, we'll take silver nitrate and we'll add it to potassium nitrate. So let me take an example here. The example is silver nitrate added to silver nitrate, which is added to potassium iodide. Okay, so when silver nitrate is added to potassium potassium iodide, then silver iodide is formed. Okay, so I have one question. We have silver nitrate. Okay, I'm still adding silver nitrate to potassium iodide. So what do you think? What is the solvent and what is the solute here? Silver nitrate is added to potassium iodide. So what will be the solvent here? That is the substance in which the component which is in more amount.
Potassium iodide.
Potassium iodide, yeah. Sorry. So potassium iodide is going to be our solvent. Okay. So when we add silver nitrate to potassium iodide, we have silver, that is Ag. Oops, sorry. We have Ag and silver iodide is formed. Okay, silver iodide is formed. So if you look like in reactions, we directly write AgI, but it does not happen like that. What happens? We have Ag plus, right? Ag plus, and in this solution now, we have iodide ions also. Now there will be obviously more iodide ions than silver Ag plus ions. Why? Because we are adding a small amount of silver nitrate because it is a solute. Solute is the component which is present in lesser amount. So obviously Ag plus will be less than I negative. So what you can think is that there will be many I negative which will come and they will stick to Ag. They will stick to Ag like this. So we have Ag I, right? So there will be many silver iodide, and this will be completely solid. But still there will be some I negative which will be near the silver iodide particles. Okay, why? Because essentially iodine negative, that is iodide ions, they were coming near the Ag plus ion. Okay, so you will form this type of layer of I negative around the solid AgI, solid silver iodide. Now, next thing that we have, which is in very large amount, is potassium. So when you have I negative here, this I negative will also attract the potassium positive ions, K positive ions. Okay, so now you have two layers, right? You have two layers. So this kind of layer is formed when you have preferential adsorption. So why is there preferential adsorption? Because iodine negative, it has some affinity towards Ag positive. Now, even when all the Ags, that means all the silver, have one iodine and one iodide ion with itself, there are further more iodine negative ions which are attracted by the Ag plus ion, and that is why you get a layer of I negative. And outside the layer, we have a K positive layer. Okay, so let me just give you a better diagram here. And how do we show this? We show it like this. We have Ag positive, we have Ag I. Okay, this is formed as soon as we added silver nitrate. Okay, then I negative, which is in the dispersion medium, we write Dm, and you get AgI, I negative. So we have got a negative solve. Now, if you reverse this, okay, if you reverse this and you add potassium iodide. Okay, what do? You add potassium iodide to silver nitrate. Then what you will make? You will be forming AgI only. AgI will be formed, but this AgI, since we have silver nitrate as the dispersion medium now, as the solvent, we will have more and more Ag positive ions, and we will get AgI and Ag positive, and this is a positive sol. So there are always two things. In the first case, we have more amount of iodine because potassium iodide is the solvent. That is why iodide negative is coming around and making a layer around the AgI, that is silver iodide, and we are getting a negative sol. Now in the second case, what we are doing, we are adding potassium iodide to silver nitrate. So we have more of silver here. So silver is getting attracted to the I negative, and that is why we are making a layer of Ag positive around the silver iodide, and we are forming a positive sol. Okay, we are forming a positive sol. So these are the formation of negative sol and positive sol through preferential adsorption of ion. So here, which ion is preferentially adsorbed? Iodine negative is preferentially adsorbed. Why? Due to excess, because iodine negative is in excess. Here Ag positive is in excess, and that's why it is preferentially adsorbed by AgI. Okay, so please write these things. Let me. Yeah, also write this table, positively charged salts and negative charged salts. Just write it once, है ना? कहीं आपके दिमाग में थोड़ा सा रह जाए. And then the origin of charge, and at last preferential adsorption. Raise your hand if you're done writing. Okay. Faisal is done. Please raise your hand if you're done. Okay, just write here. Okay, so these are two different things. Silver nitrate added to potassium hydride. Then we have negative salt. Ki added to potassium nitrate. We will get a positive salt. Faisal and Nabir are done. Please raise your hand if you're done, guys. Fatima and Sania.
Done, sir.
Done. Okay. So write one point here regarding preferential adsorption. Okay. Please remember. Okay, let me ask you one question. I am adding AgNO3 in Ki. Okay, AgNO3 in Ki. So the solid that I will get is AgI. Okay, silver iodide is the solid. Okay, it is the solid. Now, outside silver iodide, which is a solid, let me make it a bit solid. Yeah, so this is a solid. Okay. So in this solution, we have K plus ion and iodine negative ions. Okay, these are the two ions that we have. Okay, these are the very huge amount. NO3 will be in very small amount because that is a solute. That is a solute. So Ki in the dispersion medium, we have two ions, K plus and iodine negative. Now, please tell me which of them gets absorbed by AgI. Which of them gets absorbed? Tell me, guys. Look in your notebook and tell me.
So iodine.
iodine negative. Okay. Now, when we have Ki added to AgNO3, Ki is added to AgNO3. Again, we will get AgI only. This is the solid that we will get, and this solid will absorb. What it will absorb? It has now. It will either absorb Ag positive or it will absorb NO3 negative. Now, look in your notebook and tell me which of them gets absorbed.
Ag positive.
Ag positive, very good. Ag positive gets absorbed. So if you see here, the ion which is getting absorbed here in both of the cases is the ion which is common in the solid, or you also say what? Lattice. This AgI lattice has iodine, and that is why it is absorbing iodine negative from the solution. And here also AgI has Ag positive, which is common between the solid and in the solution. Ag positive is common. That is why the common one, it is getting absorbed. The common one, it is getting absorbed. So that is the point I want you to write, is the ions. The ions preferred by, please write this with me. The ions preferred by what? The colloidal particle, preferred by colloidal particles. Are those which are common with their own lattice. So Fatima, Sania, Abir, and Faisal, all of you understood this line? Yes or no? Please tell me. The ions preferred by colloidal
Yes, sir.
particles are those which are common with their own lattice. Okay, common with their own lattice. Then all of you, please tell me if you're done writing this whole thing.
Yes, sir.
Okay. Now let me show you one more photo. So as I was saying, let me write this topic here first of all. Helmholtz electrokinetic. Double layer. So it is nothing that we have not seen. It's the same thing that I was talking about. So we have AgI solid, right? We have this AgI solid, and this AgI solid here, it is attracting the iodine negative from the potassium iodide. Then this iodine negative is attracting the K positive. Okay. So now till here, this dotted line, it shows the fixed layer. Okay. So this fixed layer here, it is fixed, it is not moving, it is not moving. And outside this, we have the solvent, that is Ki, that is the diffuse layer, that is the diffuse layer. So these are the two layers, right? There is a fixed layer and there is a diffuse layer. So when there is a preferential adsorption of a particular ion to form this type of fixed layer and diffuse layer, then we say that this whole thing is known as Helmholtz electrokinetic double layer. Okay, since we have formed a fixed layer and diffuse layer, that is why this name double layer. And since Helmholtz has formed it, so it is known as Helmholtz electrokinetic double layer. All of you understood this? Yes or no? Please tell me.
Yes, sir.
right? So till here we know, and after that it is quite intuitive that iodine negative will attract K positive. Till here it is what? Till here it is fixed layer, and after that we have the diffused layer. So okay, write this with me, like this with me. When positive,
So we will draw this one.
yeah, draw this one obviously, or negative ions of electrolytes adsorbed on the surface of colloidal particles. What happens then? Then we form a fixed layer. It forms a fixed layer. It forms a fixed layer. Okay. Now, after that, what happens? This fixed layer, it attracts the counter ions from the dispersion medium and it forms a second layer. Attracts counter ions. And forms, this fixed layer attracts counter ions and forms second layer. Which is known as diffused layer. Okay, please write this down. Let me know if you're done. Guys, yes. Are you done? Abir, Fatima, Faisal, Sania? No?
Yes, sir. Done.
Yes, sir.
Done. Okay. Fatima, are you done?
Yes, sir.
Yeah. Okay. Now, so since you are in 12th standard, you know, if there is positive charge and negative charge, there will be a potential developed between these two, right? Yes or no? If positive and negative charge are separated by a distance, there will be a potential developed between them. Yes or no, guys?
Yes, sir.
Right. So since we have a negative charge here, there is a positive charge here, there will be a potential developed, and this is known as a zeta potential. Okay, this is known as a zeta potential. So write one more point. Write this with me. The potential difference between the fixed layer and diffuse layer. Opposite charges is called Zeta Potential or electrokinetic potential. You? Yabir is done. Fatima, Faisal, Sania. Okay, all of you are done. Okay. Great, great, great. So the next thing is now electrophoresis. So in electrophoresis, what do? We have a cathode and an anode, and then we have dipped platinum rods in there. Okay, we have dipped platinum rods in there. So when you have cathode, which is negative charge, anode, which is positively charged, there will be some colloid particles, and we know that colloid particles, they have charges, right? They will have charges. So what happens in the anode part? We will have negatively charged particles. They will stick up in the anode, and the positively charged particles, if there are positively charged particles, they will be sticking up in the cathode. They will be sticking up in the cathode. So it is simple electrophoresis. Let me write the topic, and then we can write the definition. Electrophoresis. So it is nothing but it is the movement of colloidal particles. Okay. So movement of colloidal particles. Movement of colloidal particles towards oppositely charged electrodes in an electric field called electrophoresis. It's called electrophoresis. Okay, so please write this down.
So do we need to draw the diagram?
Yeah, just draw the right diagram. It is like draw the diagram, not the complete photo. Okay, just a representation type of thing. Right this point. Now there's one more term which is related with electrophoresis. It is known as electro osmosis. It is known as electro osmosis. So electro osmosis happens if we prevent this movement. If we prevent this movement, then what we see is that the dispersion medium, it moves towards the move in the electric field, and this phenomena is just known as electro osmosis. So if the electrophoresis is prevented by suitable means. Then what do we see? Then we see that then DM, what is DM? Dispersion medium begins to move. In the electric field. In electrophoresis, we have colloidal particles moving, and in electro osmosis, move in electric field, it is known as electro osmosis. If you're done with these 2 points and the diagram. Hey guys, Kabir is done. Faisal is done. Okay, everyone. Okay. So after this, we have stability of salts. Okay, stability of salts. Okay, stability of salt. Okay. So I want to ask one question here. Here, what it means to be stable. So I'm giving you 2 different cases. Okay, A and B. In both of these cases, there is some dispersion medium. In the A case, we have the sol, that is the colloidal particles, like this. Okay, they are separated here and they are acting. This is like it is kind of a sol, but in the B case, we have some particles, but there are many particles which are coagulated. That means they are stick together. So what do you think, which is more stable, A or B? Which will be more stable? The one in which it is completely dispersed in the dispersion medium, or in which some of the colloidal particles, that is the small particles, they are aggregated? Which will be more
A.
stable? Okay, what about others? Fatima, Sania, Abir, what do you think? Which will be more stable? Okay, Abir. Okay, so when I talk about stability of a sol, you have to think which of them looks more like a sol. Fatima and Sana, this is to help you guys. What do you think, which looks more like a sol? Which looks more like a colloidal solution? Tell me, A or B? A, right? So A looks more like a sol, B doesn't. That is why if something looks more like a sol, that means that is more stable, right? If I'm talking about, so what is more human? A human person or an animal? Obviously, human is more stable. If I talk about the stability or the human aspect of it, right? So the one which is looking more like a sol, that is more stable sol. That is more stable sol. Okay, fine. So we understand that this aggregation is the part which is bringing destability. If we have some particles which are aggregating, that is causing us destability of sol. That is causing the destability of sol. So we have seen that there are two types of sol. There are two types of sol. There is one is lyophobic, and the second is lyophilic. Okay, the second is lyophilic. Now both of these salts, they will have some charges. Okay, so both of them, they have this lyophobic and this lyophilic. Both of these salt, the colloidal particle, they have same charge. Okay. Now what will happen if the colloidal particles, if all these particles, they have same charge here, then they will be separated. They will not aggregate. If two same charges, they will repel each other, and if they are repelling each other, they are not going to aggregate, and that is why they will be stable. So lyophobic has same charge. Lyophilic also, the stability lies in this reason that it is having same charge of colloidal particles. But in lyophilic, there is also one more reason, and the reason is the solvation of colloidal particles. Solvation of colloidal particles. Why? As you know, lyophilic means in lyophilic case, the dispersion medium and the colloidal particles, if they have some affinity towards each other, they have some attraction towards each other. So whenever there is some attraction, the solvation energy is lowered, and when solvation energy is lowered, it brings about stability. It brings stability. So in lyophobic, we have only one reason for the stability, that is the same charge of colloidal particles. In lyophilic, we have same charge and the solvation of colloidal particles. Okay. Now, and hence we can also say lyophilic salts are more stable than lyophobic salts. Okay, lyophilic salts are more stable than lyophobic salts. So this is the first point that I will write, that lyophobic and lyophilic salts both are stable due to same charge on colloidal particles. But in lyophilic salts, solvation of colloidal particles further enhances the stability and hence it is more stable than lyophobic salts. Just write these 2 points. No need to write all the above things. Stability of salt, and then write these 2 points. Let me know if you have written the 2 points. It is done. Waiting for Fatima, Faisal, and Sania. Okay, Fatima is also done. Just waiting for Faisal now. Oh, Faisal got disconnected. Okay. So next is coagulation.
Sir,
Yeah, Faisal.
sir, could you scroll up a little bit?
Yeah, sure. This much is fine.
Yes, sir.
Faisal? Okay. Okay, so coagulation is nothing but it is aggregation of colloidal particles into insoluble precipitate. Okay, so when you have some colloidal particles and they aggregate, okay, and they are not soluble now, then we say that coagulation has happened. Okay, this process is known as coagulation. Generally, coagulation is done only after adding some suitable electrolyte in the solution. Okay, so please write the process of aggregation of colloidal particles into insoluble PPT, that is precipitate by addition of suitable electrolyte. For coagulation. Okay. Now, when I talk about electrolytes here, so I think it is quite intuitive to understand that if I have some kind of sol, okay, so the sol that I'm having here, these are all positive sols. Okay, these are all positive sols. So in order to bring them together, okay, I want all of these positive sols to bring them together and to aggregate them. And so to aggregate them, what I will do, I will add a negatively charged electrolyte, right? So when I add a negatively charged electrolyte, all these positively charged colloidal particles, they will aggregate over this negatively charged electrolyte, and hence they will become insoluble, and hence they will become insoluble and into a precipitate. Okay, so this is how we do coagulation. This is how we do coagulation. And there is an obvious, it is kind of obvious that if the negative charge is very high, then the chances of getting coagulation is also very high. It is also very high. So the coagulation power, what I can say, of the electrolyte is directly proportional to the valency of the ions. Okay, so if I have some ions, let us say Cl negative, okay, and I compare this to, let us say, O2 negative, and obviously O2 negative will have a higher coagulation power because it is more negatively charged. And if it is more if it is more negatively charged, these positive particles, they will be attracted more effectively. Okay, it will be attracted more effectively, and this is known as the Hardy-Schulz rule. Hardy-Schulz rule. So what does it say? It says that coagulation power of the electrolyte is directly proportional to valency ions, or we can also say charge on ions. Okay, charge on ions. So if I'm talking about a negatively charged sol, so I will say for negative sols, Al3 plus will act as a have a greatest coagulation power, followed by Ba2 positive and followed by sodium positive, right? So if you have more charge, the coagulating power will be higher. And if I talk about for positive sols, so for positive sols we'll be using anions. So you can use complex also. You can use FeCN6 or something, which has 4 negative charge. And then followed by, you can use PO4 3 negative, which has 3 negative charge. Then we have SO4 2 negative, followed by Cl negative. Okay, so if you have more, high charge means high coagulating power, high coagulation power. Okay, so write this down about coagulation. Let me know if you're done. And there is a last topic, which is about the protection of colloids or protective colloids. You have to learn about protective colloid, and that will be it. One thing that I want all of you to write here, this will be homework. You write about coagulation value. It's one line thing.
Sir,
Yeah,
sir, could you explain this coagulation once more?
coagulation.
Coagulation, this like the topic.
Okay, okay. So you understand, right? You have to write. Okay, first thing, coagulating value. You will write this. Okay, this will be homework for you. This one line you find in the fetch and the NCERT textbook. Okay, so coagulation. You understand, Faisal? It is aggregation of colloidal particles, right? You understand till there?
No, sir.
No. Okay. Coagulation just means precipitation. Wait a second. Yeah. So when we have colloidal solution, and these colloidal particles, I want to aggregate them. Okay, I want to bring them together. So when I want to bring them together, like this. So this phenomena, it is known as coagulation. Now you understand it? Yes or no? The word coagulation.
Yes, sir.
Okay. So now it is not going to happen automatically. Why? Because all the colloidal particles, these small particles, now they have same charge. What type of charge do they have, Faisal? Same charge. Okay. Now you tell
Yes,
me,
sir.
if they have same charge, will they come together? Will they come near to each other?
No, sir.
No. So we will add some agent here. We'll add some electrolyte here. Okay. So supposedly all of these are positively charged. Okay. These are positive charge. So what did I do? I added a negatively charged electrolyte. I added a negatively charged electrolyte. So inside this whole thing, what would happen? This negative charge particle, it will attract all the colloidal particles. Yes or no? Correct?
Yes, sir.
So what now we have done? We have taken and we have got all the positively charged colloidal particles together in one place, and we have formed a precipitate kind of thing, an insoluble precipitate. Okay, so we have taken all of these positive charge and we have condensed it and we have aggregated it around this negatively charged electrolyte that we added. So this is coagulation. Okay, so coagulation is just means aggregation, and this is how the coagulation is done, by adding a electrolyte. Now, if this was a negatively charged, then we would have added a positively charged electrolyte in order to make the coagulation happen. Now you understand this, yes or no?
Yes, sir.
Okay. Now this term here, coagulating value, all of you will fetch in the NCERT and write the definition. Okay. Coagulating value. Okay, just raise your hand if you're done. Next topic is the protection of colloids. Protection of colloids. So this we have only one line, which is when you add lyophilic salts to lyophobic salts. When lyophilic salts are added to lyophobic salts, then what happens? This lyophilic salts now. So we have, let me make a lyophobic one. Okay, this is lyophobic. That means it is not very much, it is not engaging, or it is not having any affinity towards the dispersion medium. But our lyophobic one, we have now lyophilic. We added lyophilic. So what happens? This lyophilic salt, it forms a layer around these lyophobic ones. Okay, these lyophobic ones. So why? Because it wants to decrease the number of interaction that the lyophobic one is having with dispersion medium, because lyophobic and dispersion medium, they don't have any affinity. What affinity does have? Lyophilic one has the affinity. It has some attractive forces, which is with the dispersion medium. So now the dispersion medium can interact with the lyophilic salts. Okay, so that is why when lyophilic salt, it is added to lyophobic salt, they create a kind of layer around, they create a kind of protective layer around the lyophobic salts, and that is why, and hence the protection of lyophobic salts is done. So when lyophilic salts are added to lyophobic salts, the lyophilic salts, what do they do? They will form a protective layer, form a protective layer around lyophobic particles and prevent them from coagulation. Prevent them from coagulation. So when the lyophilic colloids are used for this purpose, they are known as protective salts. They are known as protective colloids or protective salts. When lyophilic salts are used for this purpose, sorry, they are called protective colloids. Okay, please write this down. Let me know if you're done. Let me know if you're done, guys. Abir is done, Faisal is done, waiting for Fatima and Sania. Fatima is also done, just waiting for Sania now. Okay, so that is it for today, guys. Just please remember to write coagulating value, okay? complete